There you go. All right, well, it's so wonderful to see everybody here today. So welcome on this lovely September day. Hopefully, some of you were able to go play some volleyball out there. I saw it going on in co-op. It looked really fun. My name is Barb Thomas. I'm a professor in the Department of Renewable Resources and also the Associate in Research in the Faculty of Agricultural, Life and Environmental Sciences. I'd like to start by acknowledging we are presenting today's seminar on Treaty 6 territory, and that we respect the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Nations people of Canada, whose presence continues to enrich and be vibrant in our communities. It's a really exciting day to be able to have this seminar. It is our third year of running the seminar series. It's really quite remarkable. We started during COVID and there was nobody in the room. And now the room is full. And we also have how many people online already? 30 people online. So it's been an incredibly well attended series, and it's very exciting for us. So our speaker today and my co-lead of this seminar series is Dr. Brad Pinno. Brad returned to the U of A in 2018 as a silviculture professor, and he teaches courses in both silviculture, forest operations, and leads the introductory field school. So many of you know him from one of those courses. Prior to coming to the U of A, Brad worked as a research scientist with the Canadian Forest Service for 7 years. He taught forestry at community college, and he worked as an operations and planning forester in northern Alberta and Saskatchewan. Not surprisingly, Brad has a BSc in forestry, which he also obtained here from the U of A. He has an MSc in silviculture from the U of A and a PhD in forest soils and silviculture from the University of Saskatchewan. He also did 2 postdocs, one in Regina and another one back here at the U of A. Brad has fast become the face of forestry at the U of A, taking his and other grad students on many field trips out to the forests in Alberta. His research covers the range from ecological silviculture to intensive management. When I first met Brad, he was a PhD student and came and did some work up at Alberta. I think he actually ended up being a chapter in your thesis.
Yep, we published it.
What's that?
It got published and everything too. It was good, yeah. Even better.
So he actually has that background behind it. So that was really fun to see where people's careers go and where they end up. His most recent accomplishment was obtaining his RPS status this past year. Congrats. On a more personal note, and in case you didn't know, Brad is a huge fan of the Riders and the Oilers, and is currently enjoying junior track and high school volleyball with his boys. Please join me in welcoming Brad for his presentation entitled The Potential of Intensive Silviculture to Increase Tree Growth and Timber Supply in Alberta. Brad.
All right, thank you very much, Barb, and thanks for everybody for being here. This is way more students than I get from my silviculture class in the same room, so this is great.
Not letting me switch the display. It usually just can be. Okay. This way. It won't show it on the other screen.
I don't care as long as I can go through it.
I know, but the other screen's what people
Oh.
are seeing.
Oh, so you want them to see it too? Okay.
Yeah.
Okay.
The screen.
Well, usually it gives me the switch display, and it's not giving me that option right now, and I'm not sure why not.
Well, right at the top, it says switch windows. Right there.
Right there?
Never used it before.
Me neither.
Or slideshows?
Oh, yes.
Or slideshows?
Yeah,
Yeah.
but usually it lets me switch the display, but it's not letting me pull this one over.
So this is the 13th.
For that.
So
Lucky number 13, hey?
I don't know what's going on. Other than I'm going to, I'm gonna do something crazy. It's still not working. I have to. Oh, I know what I'm gonna do. Here we go.
Don't show them now, that's my good slide.
Okay,
You're gonna have to draw it all right.
That's okay, I'm ready.
I'm sorry.
Big
guys.
tree. We're all good.
Sorry about that. Had to think for a second. And then I have to change this in the room. There you go.
All right, thank you, Stacy.
Sorry.
No problem. That's okay. Yeah, so thanks everybody for being here. This is great. So I want to talk about the potential for intensive silviculture in Alberta. So this isn't going to be a how-to manual for what densities to thin to or how much herbicide to apply or anything like this. It's really about the potential. It's about the idea of intensive management and what we could be doing here. So a lot of this work is based on the last few years, supported by Weyerhaeuser, West Fraser, NSERC, FRIA, and there's a lot of work, graduate students and postdocs in my lab here at the University of Alberta. So yeah, like I said, what we're going to do is talk about the potential of intensive silviculture. And what I'm hoping at the end of this is that we'll all be really excited about intensive silviculture, and then we can move on to the discussion about, well, how much of this do we want? Where do we want it? Those sorts of questions, I think, are the questions we need to have to move this conversation forward. So let's start with the first question is, why would we consider intensive silviculture? And the basic answer is because it works. Okay, so these are just these are cookies that I have in my lab. It's a bit of a fairly anecdotal, but a picture is worth 1,000 words, right? So what we've got here is this top one. These are white spruce, 37-centimeter diameter tree. This tree is 165 years old. Okay, this tree is 35 centimeters in diameter. It's 24 years old. The difference is this is a natural origin tree growing in our natural forest. This is an intensively managed plantation. Similar sized tree in, what's that? A fifth of the time or something like that, a sixth of the time, whatever it is. So we can grow the same size trees a lot faster if that's what we want. So we can do that. On the other side, that's lodgepole pine. Okay, and so these are from a thinning trial, but this tree here, 34 centimeters diameter. That was from the thin portion of the stand. They're both 40 years old. This is from the unthin portion of the stand. Got a question already? Okay. Okay.
Do you want questions at the end or during the presentation?
We can take questions now. Sure. I like questions.
So I'm looking at that pine. It looks like it's got some blue stain fungi in it. Is that
Yes.
correct? And is
Yeah.
that a hazard of doing the thinning? Is that it starts representing an older cohort that mountain pine beetle like?
I have no idea. I thought it looked good though. I don't know, but I think when we're talking about this is time is one of the things, and age can replace time with size. That's one of the things we're going to come back to. So I don't have an answer to your question, but I do have some thoughts on that age for time kind of substitutions, and that's, I think, essentially what you're asking about there. So yeah. But the long and the short of it here is that silviculture works, okay? We've seen this all over the world. Doing more intensive management works. We get bigger trees in the same amount of time, or we get, we can grow trees faster, right? So that's, yeah. So let's get a little bit more detailed about what's going on in Alberta and why we might be considering this here. Some of the wood supply challenges in Alberta. This was the summer of fire, right? We had fires all over the place. But there's always disturbances in our forest. We've got fires, we've got insects, and we've got diseases. We've got lots of things that want to use our forests as well as us. So that's a bit of a challenge. And if we're not harvesting them, something else is going to get them, most likely, right? So that's a bit of a challenge. Another one is industrial disturbances or industrial developments, I guess. And this is a picture from around Lodgepole. You can just see all the well sites in there, see all the roads in there. And that one, when I think about this, that's pretty concerning, just that the area in Alberta is being converted to non-forest use. Even with the reclamation requirements and things like that, there's a lot of land that's coming out of forest production every year. Another one we need to be thinking about is protected areas. Okay? There's a lot of other demands from our forests. Woodland caribou is a current one, but there's been other ones in the past, and there'll be more in the future. We're demanding a lot more things from our forests. Protected areas, biodiversity being one of them, right? And what that means is often is protected areas set aside from outside of the realm of forest management. So all this, what this means is there's less land for growing timber. So if we want to maintain our harvest rates, if we want to be able to harvest sustainably as much timber as we have in the past, we need to increase the growth on the remaining forest, right? So that's the only way. Other options would be things like reducing our harvest rates, okay? Which is also associated with closing mills and things like that. That could be another potential option. Probably not as desirable though, simply because of all the social implications of doing that. So with less land, we have to grow timber faster on the remaining land base that we have. And that's through the intensification of silviculture and forest management. The other competing side to this is a couple of years ago, there was some desires from the government to increase harvest rates. I think the number was 13%. We kind of talked about it much lately. But in and of itself, I don't think that's a particularly astonishing number or unachievable goal. I think it's very achievable through the use of more intensive silviculture practices. Now, where do we want to do it and how should we go about doing it, I think are really the questions. But 13% increase in volume production is really not all that much from my perspective, at least. We kind of have competing goals here. But the idea is with the land that we have left that's been allocated for forestry, we're going to need to increase our timber production on that land in order to maintain our timber production rates. Okay. But have no fear. There's huge potential in Alberta, okay? I like showing this map to everybody. It's one of my favorite maps. It's a map of timber productivity across Canada. It's an old map from NRCan. What it shows the timber productivity in different regions. And the darker the color, the more productive the forest is. And we can see, not surprisingly, the most productive land is on the coast of BC. That makes sense. But in terms of the boreal forest, the most productive boreal forest in Canada is in Alberta. And it's this big green area in northern Alberta there. That's the most productive boreal forest in Canada, and it's all in Alberta. And the reason for that is our soils. Okay, we've got young glacial origin soils, so they're only like 10,000 years old, which is really young for soils. So they're unleached, they've got lots of nutrients in them. They tend to be fine textured, so they have high water holding capacity. And they're quite deep, so they've got a lot of soil volume there to work with. These are really, really productive soils. We kind of contrast that with what's happening in the Eastern Boreal. Much of Northern Ontario, Northern Quebec, the biggest part of the Boreal is on the Canadian Shield. We tend to have thin soils, sandy soils over top of bedrock. So even though our climate is not particularly conducive, tend to be quite dry here, we have the best soils, and that's what makes us most productive. Okay, so similar regions around the world, when we've switched from natural forest to managed forest, I've seen about a 3 to 4 times increase in productivity. And I think we're well on our way to seeing the same thing here. Okay, so we can easily increase productivity of our forests. So natural stands some numbers here. Mean annual increment, which is essentially just the annual volume production from the forest. Natural stands 2 to 4 meters cubed per hectare. Other parts than that already here. With basic silviculture, we can bump that up a little bit. Silviculture, I don't think there's any reason we couldn't be in the 6 to 8 and probably even higher than that in terms of production. Okay, so one of the classes that I'm involved with is the Introductory Forestry Field School. Last week we were doing some timber cruising because that's a field school, a whole bunch of trees. We were in a 50-year-old stand, post-harvest pine stand, which had natural regeneration, had some thinning done in it, but it had a volume of 300 cubic meters per hectare based on the data that our students collected. So 50 years old, 300 cubic meters, that's an MEI of 6 right there. And that was not a particularly productive site and not really intensive management. And we were already an MEI of 6. So already we've got, I think that kind of shows some of that potential. So we've got some of this, we've got big potential for growing trees in Alberta. And it's only getting better, okay? So site index is increasing over time. So what we've got here, this is a figure of site index of harvest origin stands, so regenerating stands post-harvest, starting in about 1975 up until the newest ones were about 2008, I think was the most recent data that we had. And what this was is from a series of permanent sample plots in the Weyerhaeuser-Pembina FMA around Drayton Valley. What we can see is an increase in site index over time. The older stands, 1975, 80, natural regeneration, not much planting at the time, and they were kind of in the 14 to 16 range. That's kind of our natural site index in much of the boreal. Now our average was over 20 more recently, and lots of sites that were over 22. So really big increases in site index, and essentially this is due to silviculture. Okay, so we're planting trees, we're doing site preparation, we're doing competition control. There really isn't much of an impact of tree improvement in here yet, just because most of this is happening before that was big. So it's only going to increase now in the future. We're going to have bigger increases in the future. Okay. Other things that are going on here, is there a climate impact? Perhaps. We didn't really try and tease any of that out, but one of the big limiting factors we've got in the boreal forest is cold, wet soil. So if we're having a hotter, drier climate, that's probably going to alleviate that. It's probably not sustainable, but it probably is happening as we, it's probably in part of this as well. Yeah.
When you looked at site index, did you look at so you were using, I'm guessing, tree height. Did you look at the productivity of the site as kind of baseline as to show that's increasing? And the other concern that I might have that you might want to consider, or maybe you already have, is that when you look at harvested stands, I would argue that the stands that we've harvested kind of historically have been on the good sites. And so as the timber supply starts fluctuating a little bit, we're going to be forced to these poorer sites for harvest. Have you considered that as well?
Yeah, absolutely. So start with harvest the best sites first, right? That's what we do. That's the norm of how developments happen. So a lot of that was probably happening in here. So I think a lot of the best sites were actually happening in these older, stands. I do kind of move past that in the last 20 years. I think it's first sites, and we're still seeing that increase in productivity, that increase in site index. But I'd also say there's nothing strange about this. This is what we see everywhere in the world where they switch from a managed or from a natural forest to a managed forest. Okay, if we look in the Pacific Northwest, if we look in the Southeast US, this is what we see. So the inspiration from this graph came from something that I got from Tom Fox at Rainier in North Florida, and it just shows their site index increase over time in loblolly pine, and it's shockingly similar in terms of the slope of the line, and everything that they're seeing is exactly what we're seeing here. So this doesn't surprise me at all. This is what we should expect as we're switching from natural forest to managed forests. Okay. The other thing is that we can't really use the past to predict the future. Our managed forest is not growing like our natural forest. For a little bit of context about site index, as the relationship between site index and volume is not linear. It's highly exponential. So little increases in site index have big implications in terms of the volume production in a stand. Okay. So one of the concerns that I guess I have, I'm going to talk about some of the metrics that we're using in forestry, and maybe some things that we could be considering if we're looking at adopting more intensive silviculture. But currently we model by stand compositions. We lump all the spruce stands together. We lump all of the pine stands. We lump all the mixed woods together. So whether they're growing on a good site or a poor site, we lump them all together, and that's how we do our modeling. But another option would actually be to group by site productivity. Okay, so then we could make some better predictions about not just average stand growth, but more specific stand growth, what we could expect from them. So I think that's one thing we could be looking at, is understanding site productivity a little bit better. Okay, so intensive silviculture. what are we talking about here? So what are the different treatments? So establishment. So that's getting the right tree in the ground at the right time in the right place. All of that. So we're planting the right species, the right genetics as soon as possible. We've got site preparation to reduce site limiting factors, things like that. We've got competition control, and that's what we've done up until this point. Is we focused a lot on establishment and competition control. I'd argue that we've been very, very successful in Alberta at doing just that. We've got really quite productive forests here now. The new part that we're getting into is the density management. That's kind of the next phase in that. So that's kind of what we're focusing on now, and that's what a lot of our research the last few years has been about, is about density management. Okay, so a lot of the examples that I'm going to have are going to be focused on this part, but it kind of assumes that we've done a good job on the establishment and competition control to make that possible. There are some, So I'm also going to try and talk about some different scales. So everything from individual tree scale, so how are trees growing? Okay, that's important. Also, how are stands developing? That's important. And at this landscape level, what does this mean in terms of sustainable harvest rates? So I think one of the things I find really exciting about forestry is this range of scales. We're talking from individual trees to hectares in scale, right? That's exciting. We're talking about time scales from establishment of a few days to multiple rotations. So we've got these vast scales that we're dealing with, vast differences in scales. And for me, that's one of the exciting things that we're doing here. The other thing that's important here is the different metrics. So I will just kind of highlight those as we go through what I think are some of the things we should be thinking about in terms of different metrics to get it more into intensive silviculture. But I'm going to start now with kind of what's the individual tree responses. So I've got as examples things from a variety of different studies that different graduate students and postdocs have worked on in the last few years. We've got kind of operational studies. We've got more traditional experimental studies. We've got some modeling work. All of those different things is kind of going into this. And I'll just throw them all together and we'll come up with the story here. Okay, so individual tree. The takeaway here is that trees in thin areas grow faster. Okay, I think we know that it works essentially all the time. When we reduce competition, the remaining trees grow more. Okay, so by thinning the trees out, if we remove half the trees that are remaining have access to more resources and they respond and grow faster. Okay, so that's the number one takeaway here. So this is some data from a commercial thinning study. These are the thin trees in the thin stand. This is the unthin stand. Those ones are growing on average more. There's a lot of overlap, right? So it's more nuanced than just trees grow more. There is a lot more to it than that. So some of the things we found is that the medium-sized trees respond most to thinning. The best predictor of tree growth is tree size. Bigger trees grow more. But in terms of response to thinning, it's actually the medium-sized trees that respond the most. The biggest trees, the dominants in the stand, by definition have access to more resources, right? That's kind of how we define them. They have access to all the resources that they need, so they actually don't respond to getting more resources in thinning. Maybe a little bit, but not that much. The co-dominant trees are the ones that are probably have some competition from the bigger trees and the smaller trees around them. They're the ones that are responding the most. So it's the medium-sized trees that are responding. And again, the small trees, doesn't matter what you do there, they generally aren't responding all that well either, whether it's genetics or leaf area or whatever it is that's keeping them from performing. They're not doing great either. So there is some, the size of the trees does matter here. The other one is how long does growth response last? That's another one we wanted to know about. Okay, we have a lot of studies where we might do something a long time ago and then we waste 60 years to measure them now. We've got a lot of historic trials in Alberta, which are great, but maybe we haven't followed up and measured them in a long time. And what we're finding is that the growth response of individual trees to thinning doesn't last all that long, about a decade, 10, 15 years sort of thing. But it doesn't last forever, okay? And that's this figure here. In the short term, so immediately after harvest, there's a big increase in growth in thin versus unthinned. But 40 years later, the trees are growing about the same in them. So there's a short-term growth response to thinning. But the other neat part about it is that change in growth that's only 10 or 15 years actually results in long-term structural changes in the stand. Okay, so we've got more bigger trees in the forest or in the stand in the future than we do in unthin stands. And that's kind of this figure down here. These are thin stands. These are just diameter distributions. These are the unthin stands. These are the thin stands. And you can see we've shifted them over. So even though the growth response doesn't last 50 years, the legacy of that growth response does. Okay? Yeah. So trees grow more. That's good. Now let's look at looking at yield curves. So these are modeled yield curves based on some regenerating stand PSPs. We divided it by site quality. The first takeaway here is that there's big differences in productivity between the site quality. If we go fair, medium, good quality sites, it's about a 1.5 time increase from fair to medium, and about a doubling to the good quality sites. So again, that exponential relationship between site index and volume production. So the other thing that we see here is the solid lines are thin stands, the dashed lines are the unthin stands. We do see a reduction in volume, in standing volume with thinning. Okay, so that's a bit of a red flag. Whoa, maybe we shouldn't be doing this. We thought trees are supposed to be bigger, right? So is this a concern? Well, this is also fairly common. What happens during thinning is you're reducing leaf area. Okay, you reduce leaf area, the stands aren't growing as much, and that's reflected. But the trade-off is in the individual tree size of the trees that are left. And that's this bottom graph. And this is just piece size, so meters cubed per tree. Again, they're growing. This point here, where that increase, that's referred to as a chainsaw effect, is essentially that's average tree size, and you removed a bunch of the small trees, so the average tree size just mathematically increases. So that's not really a growth response yet. It's after that. We're then growing on a very different trajectory afterwards. So after that, after thinning, the trees are then growing a lot faster, and that average piece size is increasing quite a bit. So the message here is that thinning increases individual tree growth and merchantability. That's what we want. That's what thinning and intensive silviculture does. So let's look. Oh.
It's having a bit of a mic problem.
Oh, okay. Oh, because I'm walking here and back. Okay. Is that better? Okay.
We'll see if they can still hear you.
Okay. Okay. So next one. So we had a bit of a red flag. Okay. Thinning increases growth. Now we're going to look at stand level merchantability. We saw that reduction in volume. Bit of a red flag, right? So we wanted to look at other ways of. What we've been doing is using cumulative volume. So it's not just about the standing volume in the stand. It's also about the volume that's removed at the time of thinning. So we've done a few studies where we've looked at this, and what we found in every time that we've done this is that the cumulative volume is greater in thin stands than in unthin stands. So what that is that's the volume removed at the time of commercial thinning, plus the standing volume or the growth post thinning. These are both examples. This is the thin stand. This is the unthin stand. This is the thin stand. This is the unthin stand. The cumulative volume is greater thin. The standing volume might be greater in the unthin stand, but the cumulative volume is greater in the thin stand, and the individual trees are much bigger in the thin stand. And what this is basically capturing natural drain. So those are the trees that were going to die. You go in and you thin them out. You're able to take that and utilize that resource for something rather than having the trees die on you. So that's the capturing natural drain. And then we also get the growth response after the thinning as well. So we need to incorporate both of those ideas. It's not just about the standing volume. It's about the total volume we can get from the site. So that's the volume. What about time? Time is the other one I think we need to be considering a lot more. So this is a pine stand merchantability. And one of the things we've been talking about in my lab group is, well, what's our goal here? Is just bigger better? Is there a size of tree that we want? And when I kind of think about it, in terms of saw log production, at least 20 centimeters diameter is kind of considered standard in Alberta is about 13.5 centimeters diameter, but it would be hard to make a living on all 13.5 centimeter trees, right? So having 20 centimeter trees, that seems to be the cutoff between what would be a good saw log. There's also less of a premium for a lot larger logs, so there's not a whole bunch of value for growing huge trees either, but getting 20-centimeter trees is probably good. Maybe that's not the right number. I don't know. This is what we kind of came up with. Maybe it's smaller. Maybe our sawmill technology is different now, and it's actually a smaller number. Maybe it's actually bigger than that. I don't know. But it's a starting place, right? But the idea here is that not all volume is the same. It's not just about volume. It's about having the right volume, the right size of trees, that sort of thing. We don't want all 13.5-centimeter trees. So what we did here is the metric wasn't total volume or even merchantable volume. It was number of trees greater than 20 centimeters. And in this site, when we did more intensive management, which was pre-commercial and a commercial thinning, by age 50, we had 548 trees that were greater than 20 centimeters diameter, okay? Without thinning, this was a modeling study we did here. Without thinning, it took until age 80 to get a similar stand in terms of number of trees greater than 20 centimeters. So that's a savings of about 30 years in terms of having a very similar stand to harvest. Similar merchantabilities, but we can get this one 30 years sooner, which is so at the stand level, thinning increases potential volume removed. Okay. So at the stand level, intensive management and thinning works. Now let's talk about landscape level. And for this, I want to talk about a case study with the Pembina FMA. So this is warehouse FMA, Drayton Valley, Edson, 1 million hectares between there. Predominantly conifer forest, lower foothills forest. My caveat for this is we did all of this analysis before the fires this spring. So they had about 200,000 hectares or so burn this spring. But I'm going to kind of come around to that in a different way, because I think we do have some things that can then help us address that in the analysis that we did. But what we did is we wanted to model different silvicultural scenarios. Okay, what would happen? What happens to our landscape scale AAC, or annual allowable cut, sustained yield, however you want to talk about it? What happens with different silvicultural scenarios? And so we used Patchworks, which is a timber supply model, to actually model that out. Okay. The challenge with this, the challenge that they're facing with this FMA is pretty common, and that this is referred to as a kind of midterm supply, timber supply gap, is that there's not enough trees that are 20 to 40 years old that are going to be ready to harvest in 20 to 40 years from now. Okay, we just haven't, there just isn't enough in that age category. There's lots of old forest, and as of May, there's a whole bunch of young forest. We don't have a lot in that middle-aged forest that we need to fill that gap in 30, 40 years from now. So what happens in terms of timber supply is we try and stretch out the length of time we can harvest our natural forest, which increases the risk up to the forest as well. But we try and stretch that out as long as we can until we get enough of the young forest on line to harvest. But what that does is it actually results in a substantially lower annual allowable cut or sustained yield by doing that. So that's a fairly common challenge in many of our forests in Alberta. So for this analysis, we focused on, this was a preliminary analysis that we did. We focused on the regenerating conifer stands. So that was the pure pine and the pure spruce. We didn't look at the mixed woods or aspen stands. But this is a conifer dominated forest. So we wanted to look at different scenarios. So we did some timber supply scenarios with no thinning, referred to as controls. We had some with thinning. And we want to evaluate the impact of different constraints in our timber supply. So one of the ones that we looked at was minimum harvest age. So in the forest management plan, there was a set minimum harvest age of 70 in this area. Okay, so right now the forest management plan says they can't harvest stands until they're 70 years old. But what we were seeing earlier is that if we were doing more intensive management on good sites, those stands should be ready to harvest at 50. So we changed that assumption. Is if you did intensive management and were thinning these sites, they were available for harvest at age 50 rather than age 70. Okay, if you didn't do any of that, you couldn't harvest them until they were age 70. That was kind of one of the assumptions that we looked at. The other thing we did was index. So we're spatially mapped, but we do have an indication of how much of the land base is in each of those different categories, and we just randomly assigned stands to different site productivities. So that way, we divided it up by site productivity. The other landscape scale constraints, things like wildlife habitat requirements, things like cereal stages and watershed constraints. We left all of those in there. We didn't want to change those. We just left them in there and did it. We just really evaluated the ones that we had control with more silviculturally. Okay. Okay, so what did we find? So our main response here is conifer AAC. So that's a sustainable harvest rate of conifer trees from this landscape. Okay. So our baseline scenario was no thinning. Our AAC is about 1.1 million. For the non-regenerating conifers and for the mixed woods and for the aspen stands, we actually just used their existing yield curves for this analysis. And that we only used our yield curves that we developed for the regenerating conifers. But the number 1.1 million is about what it is already. So we're probably in the right ballpark with the analysis that we did. On the other side, this is just the conifer. The deciduous, there's about a 500,000 cubic meter annual AAC for deciduous, and it didn't change in any areas, but we didn't do anything with the deciduous. But that's kind of where our starting point is, okay? And we'll use that to evaluate which the different scenarios here. So the first one is, what if we just applied thinning? And as thinning is the model too, so Patchworks will just apply thinning every year to however many stands it does in order to maximize the amount of timber production. But when we did that, we got an increase in AAC rate for this forest immediately, okay? So that's an important part here, is if by doing this, if we committed to doing more intensive management, it increases the growth of the forest. And what the model is telling us is we could increase harvest rates today by 16%. So that's essentially what that is the allowable cut effect. So we're increasing the growth rate of the forest. We can harvest more timber today from the existing forest. We don't need to wait until those stands that we're thinning to mature in order to harvest them. So we can get the benefit of it today. So that's a huge one, okay? So that's what we're seeing here, about 16% increase. The weird things about Patchworks is it applied thinning to maximize AAC. So actually some years it had thousands of hectares of thin, some years it had none. And it was so, the average is about 800 though. So we thought, okay, well, what if we just applied a standard of 800 hectares per year thinning of our conifer stands? What would happen? We got about a 6.4% in AAC. So still, that's quite substantial. Yeah.
I missed that. So is that picking stands to thin that are on good sites? Like what is the mechanism for choosing the stands?
Yeah, so I didn't go into detail on that, but yes, that's exactly right. So we did have rules around thinning, which ones we could thin, which ones we couldn't thin. So we only selected sites for more intensive management, so for the thinning regimes, on our good and medium quality sites. We didn't bother with the fair sites. I think there's some potential there, but we didn't include it in here. We also had a maximum of only an operational constraint. Some will be too far from roads. Some will have other values that we're trying to manage for. So put it in half as for that. The other thing I thought was interesting from our analysis is that there was lots of pine stands that were ready to go now. We've been growing pine sites that are ready for thinning now for a while. Spruce were a lot more challenging. A lot of spruce stands that we didn't think were ready for any sort of thinning or intensive management on them. They didn't have enough density, whatever. So I think that's a reflection of there's been more challenge in the past with spruce regeneration. I don't think that's necessarily the case going forward, but we did have some timelines on when we could start thinning like the pine stands versus the stands. But the pine stands were ready to go. The spruce stands were not, essentially, is the message there. Yeah, does that make sense? Okay. But the landscape scale thinning increases the sustainable harvest rates. Another one, this is a surge or disturbance scenario. So surge cut this is what we've done if we're interested in harvesting all the pine we can to reduce mountain pine beetle risk. Harvest as much pine as you can in the next 10, 20 years. That could be the scenario, or it could be a big fire comes through and burns a whole bunch of land, which is what we found this year, right? So either one of those, essentially they're kind of the same thing, is that we're using up a whole bunch of timber in the first period, and what's the implications of that in the long term? So whether it's through harvesting, whether it's through insects and disease, whether it's through fire, We're using up a whole bunch of timber in the first period, and what's the long-term implications of that? Well, if we do nothing, our long-term harvest rates decreases by about 7%. Pretty substantial decrease in harvest rates if we don't do anything now. So what's the potential for thinning and intensive management to mitigate some of that? And this is assuming we start thinning today. One is that we can handle a much bigger surge or a much bigger disturbance today, and it doesn't decrease the long-term AAC for these forests either. So to me, that is, of all the things, this might actually be the biggest one is when we're talking about fires and we're talking about disturbances like that, the general thinking is that, well, we're just going to reduce our AAC levels. Well, maybe we don't have to. Maybe if we can get into more intensive management, we can actually absorb a lot more of that. In the paper that we wrote on this one, Vic Leifers was the lead author on it. We talked about the potential of intensive management to increase flexibility. We have more options. Okay, so we can absorb more shots, whether it's through mountain pine beetle plants or whether it's through fire or whatever it is. We have more options when we're thinning than when we are not thinning. Okay. Last one about the landscape scale here is kind of coming back to individual trees now. Okay. When we worry about the size, we've said that future forest is growing different than our natural forests. Okay. I'd also say that in general, the timber profile is going to be very different in the future as well. But here, this is log size, so average piece size, meters cubed per tree. We have this precipitous drop at about 40. That's when we're switching from natural forest to managed forest. The managed forests that we're going to be harvesting at that time are simply not as big. They are much smaller, and that's huge. We're going from almost half a cubic meter per tree to about 0.3. That's a major drop, and this is what most plans are showing. And that's if we're not thinning. If we are thinning, though, what we're showing is with thinning, we can maintain that piece size. So that's great. If we're interested about future wood quality, more than just total volume, we need to start thinning now. The other thing is we can't wait until 2067 when the cliff hits. You got to start doing it now. Have the stands and the trees ready to harvest in 2067. We got to start implementing these things now. Most forest areas in the province are facing something similar to that. Okay, but what that means is we've got time and we can start doing it. We've got good growing sites. This is possible, I think. Okay, so hopefully I've convinced you all. We've got intensive silviculture can increase tree growth, increase stand productivity, increase the volume from a single stand, reduce time to minimum merchantable harvest age. At the landscape scale, it increases. No brainer. A couple of years ago, I wrote a paper about exactly that. Is why aren't we doing this? There's lots of reasons, lots of good reasons, but this is insecurity of land tenure. This is public land. Are people going to invest in land they don't own? Well, or don't have secure tenure on. Maybe not. Forest regeneration standards, not intensive management, or you're a quota holder or something like that. Some challenges with doing that. We're managing for volume rather than value. In the natural forest, all volume is somewhat equivalent. Okay, it's more big tree. But in the future, we need actual products that we want to be producing in our forest. So it's value, not volume, that we should be thinking about. And that's that idea of the 20-centimeter saw log. Long rotation lengths, long modeling periods, they really discount the value of intensive management. If you can't reduce the time, there's no way you're going to do intensive silviculture. It's all about time in that regard. Our models don't have it. We can't project what this is going to be in the future. We have a real hard time adopting them, right? And there's also, perceptions. Intensive management is uneconomical. We have an idea here that trees just don't grow very fast here, but that doesn't need to be the case. Yeah.
Are you missing a circle there? Maybe one that says stochastic events. So unknown stochastic events, size of unknown stochastic events. So you go make an investment, it burns.
Yeah, risk. Risk is a huge one, right? Yeah, so risk is one of the big ones, and maybe, yeah, that is, I think when we talked about it, we actually had it in terms of insecurity, we just don't know what's going to happen on that land. There's a policy side, but there's also kind of the environmental side of that insecurity, but that's related to risk, and that's a huge one. Yeah. But what's not on this list is that silviculture doesn't work, because it does. Okay. We don't have on this list that we're unsure about whether or not we can grow trees faster, because we know we can. So that's not one of the things that's keeping us back. There's lots of other things and lots of valid concerns here, but it's not because we can't do it. Okay. So I just want to talk the last few minutes here about some of the other things that if we are interested in this, and if we want to continue this discussion, what are some of the things that I think we need to do to make this potentially more viable? And risk is my number one, right? So just as Andy was mentioning, is very, very high. I think we've seen that. I would also say even more important than that is risk to our communities and things like that. Okay, it's more than just than timber, of course. But in my thinking, intensive silviculture is very, very similar to climate smart forestry, right? So this is a picture from a community fire smart treatment outside of Calling Lake. We visited this one in our field school this year. To me, that's a pre-commercial thinning. That's all that is. They're about 90% the same. Okay. Yeah, there's a little bit difference here. Okay, but it's about 90% the same. So how do we start doing these things to meet multiple objectives? It's more than just about timber. How do we do this to help protect communities? Maybe in black spruce stands like this, that could be the government responsibility. Maybe in the pine stand that extends for 10 miles beyond it, that could be the forest manager's responsibility. Decreasing the risk to that community of fire and other things, increase timber productivity, right? So how do we, in terms of the climate side of this, much of the thinning that's happening in Western North America right now is being done for climate change adaptation, and it's for drought. We're expecting more droughts in the future. By thinning forests, we get fewer trees. Each tree that remains gets more water, should be more resilient to drought, right? So can we start doing more of those as well as productivity goals? Climate change adaptation, the next part is the more we can turn these stands over, the more chances we have at adapting them, right? So if we're talking about tree improvement now, if we're harvesting every 40 years versus every 100 years, we're getting 2.5 times more opportunity to use the best genetics that's the most adapted all the time. So there's lots of ways that how do we combine these things and meet multiple objectives? I think if it's all about timber, it's going to be a hard sell. But I think it's about timber, it's about risk reduction, it's about climate change adaptation, it's about all those things. And we can meet multiple objectives with more intensive silviculture. Okay. We design these in the landscape, but I thought you kind of get the idea there, I think. Another one is kind of time. And I've talked a lot about time here today, but we have this perception that trees take a long time to grow in the boreal forest. They don't have to. We can grow trees fast if we want. It's a choice. It's a management decision that we're making for the most part. There's lots of variability out there. Really, it's a management decision, okay? So a commercially thin stand at age 25. So we can have merchantable trees coming out of that stand at age 25. We don't have to wait till age 80 or 100, right? So that got me thinking, okay, instead of looking at total volume or MAI culmination age, maybe we should be using structural characteristics. So instead of having a minimum harvest age of 80 or 100 in some FMAs, maybe our minimum harvest should be when trees reach this size. And however you get them there, great, but you can't harvest trees until they reach a certain size. Maybe that's a different way of looking at it. So instead of time being, it's size of trees that's everything, okay? I think that would be a way we could incentivize doing more intensive management if we could get away from minimum harvesting long. That stuff too, but I suspect the same thing goes for habitat and biodiversity requirements. Is it really old forest that we're looking for, or is it forest with certain structural characteristics, having big trees, widely spaced, things like that? Can we start replacing time for structural characteristics? I think we can. Okay, other things. Metrics. The future is going to be different. We've got to start having different, we've got to start measuring different things. Right now, our main metrics quite long. There's a big penalty for that slight reduction in volume in terms of the culmination age of thin stands tends to be longer than an unthin stands, things like that. But this isn't about total volume. It's about being able to harvest the stand as quickly as possible. So MAI is our wrong metric. And again, in terms of volume, it's not the total volume we're interested in, it's the volume that we want that we're interested in. It's not total volume, it's the volume of saw logs if you're a sawmill. Maybe something else you're after, but it's not total volume or even merchantable volume. It's the volume that you're interested in and you want to grow. We need to focus on that more than on total volume. And then another one we have is we often describe stands by averages. But it's not about the averages, it's about the distributions is probably more important. It's not the average tree size, it's how many trees are of different size categories. So how many big trees have we got? That's the number that we really want to know. It's not about the average, it's about the distribution. Another one here on models. So we rely a lot on models, and they drive a lot of what we do in forestry. So this is our two main models that we have in Alberta for growth and yield, Gypsy and MGM. Both of them are problematic when it comes to intensive management, okay? So Gypsy is, it doesn't have for thinning interventions or anything like that. So you can't even apply them in the model. MGM, you can apply them, but it hasn't been validated fully. So there are some challenges with using them. We need to use models though. We don't have a history of 100 years of every different silvicultural treatment out there that we can go and evaluate. We need to use models to do it. So there needs to be continued effort in developing these models and maybe new models. I don't know. I'm not a modeler, but I do want to be able to use them. So it's really important that we have good models for us. Some of the work that we have done looking at, and the modeling work that I did show you, we did using MGM, just so you know. But one of the things that we found is that the density independent mortality, we're way off. It's that kind of the stochastic mortality. I think it's built into these models. I don't really know how it is, but I think it's built into the models as kind of average mortality over time. But what we're seeing is that density independent mortality tends to come in waves. So it'll be either patchy or in certain years, it won't be continuous over time, right? So if we can get a better understanding of density independent mortality, that would be great. We know how trees work in terms of density dependent mortality. We're very good at that, but the density independent mortality is a big one. The other one is site index prediction. That's a soils map from northern Alberta. How can we relate that to site productivity now? We've done some of this work in natural stands, but we haven't done it in managed stands. So I think we need to, moving forward, we need to look at, can we predict site index from basic soils and site information that actually we have the best information in Alberta about this already. I don't think we're fully utilizing it. So we could be using more of this sort of thing in Alberta to really get an idea of site productivity. It's not just stand composition, but site productivity. And then other tools, stand density management. So FGRO has developed a whole bunch of stand density management. And we need more tools like that. We need more tools to help practitioners make some of these decisions. So I said this wasn't going to be a lecture on, what density is the thin to or anything like that. But when we're going to apply this, we do need those tools. So we need to keep developing them. And it's not just one iteration of them. We need to continually keep developing all these tools. Okay, our last one, our forest management objectives. This is pretty big. What are our forest management objectives? If I'm crystal balling here a little bit into the future, there's going to be way more demands on our forests and on our foresters in the future. We're going to have tons of demands placed on us that we don't have currently or haven't had in the past. It's going to be for all those ecological values, all the social values, recreation, whatever it's going to be in our forest. We're going to have huge demands placed on that. And it's going to be challenging to meet it. A lot of we're managing what I refer to as sustained yield with constraints. We're not really co-managing for multiple objectives. We're really managing for timber productivity and our timber supply analysis while meeting a suite of other constraints. So it's, I think that will be expected to change in the future. I just think that's what's going to happen when I'm looking around at other jurisdictions as to see where the world is heading. So how do you accomplish that? We might think, well, intensive management has no place in a world like that. Well, I think there is a potential for it. One of the options is this triad zoning approach, right? You might be familiar with this, but it's kind of dividing landscape into different areas. One area for intensive management, one area for more ecological management, and one area for protected areas. So we can talk about what those how big each of those areas should be, where they should be, all of that stuff. But the idea is, instead of trying to meet all of the requirements everywhere in the intensive management zones, we focus on growing trees fast. In the ecological zone, we extract some timber, but the main goal there is more ecological values in our protected areas as well. So we're going to have more requirements to do all of these things in the future. This is my example of ecological forestry here. We've got shelter wood, mixed wood management, natural regeneration. We're going to have to do all of that in the future. Okay, we're going to have way more of all of those things. And in order to pay for that, and by pay for that, I'm talking about in terms of timber, the only way that I think we can do it is by having more intensive management. So if we're going to do those things, if we're going to have more variety of silviculture, we'll have more extended rotations, natural successional patterns, all those things, and they're all great. We should have more of that in order to compensate the timber volumes. We're going to have to grow more area, and we're going to have to grow it faster like that. Okay, so I think they do go hand in hand. And as we get more of these constraints, it does, to me, it makes intensive management even more important, not less important. Okay, so we'll wrap up here. Intensive silviculture is possible. Let's do it. I think we need to rethink what we're doing. That's not the question, is whether or not it's possible or not. The question now is, where do we want it? How much do we want? We don't want this everywhere, but where do we want it? Where does it make the most sense? That sort of thing. And then how do we implement it? But hopefully I kind of demonstrated that intensive silviculture increases tree growth, increases stand productivity, increases AAC levels at the landscape level, does all of those things. And I think as we start incorporating other forest values, intensive management is going to become even more important in our forest management system. And to get the benefits of that, we really need to start implementing it now. We talk a lot about it, and sometimes I feel like we're looking for the perfect solution. I think we can start doing this in a lot more places and meeting multiple objectives. I think we can start implementing it now in many cases. So I will leave it there.
All right, thank you, Brad. Made me so happy. I think I heard you use the word genetics 6 times.
6 times? Oh, you're marking it down. Oh, well.
All right, well, we will open the floor up here for questions. People want to think about it for a minute, or do we have any online yet? No? Okay, so I have a question.
Okay.
So, when we went to New Brunswick and looked at on that silviculture tool, they are using a site index at age 25.
Mm-hmm.
We use site index at 50. Which now becomes a problem if we're going to harvest trees at 40 or 45. So that's a complete rethink. So maybe you can walk us through how we address that problem.
No, but of all the things, so we went on a tour because it's a huge problem. But it's we went on I don't know, a productivity tour to New Brunswick, a whole bunch of foresters and some folks from the university here to New Brunswick. And actually, that was the one thing that I started big in my notebook, was about this change in site index from age 50 to age 20. So one of the challenges with site index is that's our metric for productivity. And normally what we've done is site index has normally been assessed at about half the rotation age. So in the past, 50 maybe made sense in Alberta. But now as we switch to age 40 or 50, it doesn't make sense anymore because you're never going to get there in most of our stands. So what do we do? I don't know, but I think we can start thinking about switching to a base age of 20. The other big change in site index has been from breast height age in natural forest to total tree age in managed forest. That's another shift I think we have to make. Yeah, so site index is a big one, and I think site index is really important, and it's driving everything in terms of productivity. Everything that we're doing is about site index, or a lot of it is about site index. So we better have a good indication of it. I think there's a lot of challenges with predicting site index at age 14 at performance standard age here. So I think site index is a huge topic that we really need to be thinking about a lot more. But I don't have a specific answer to that, but I think it's a super important topic.
Charles, please turn on the mics when you ask your question.
Yeah, so just following up on that, like the slide you presented earlier on the site about site index
Yeah.
is really interesting. I'm just wondering, thinking about 2005, that integrates like the past 50 years. There's definitely missing, 2 tough decades. And on the other side, height, being less sensitive to the changing grow environment than diameter.
Yeah.
Like, yeah, do you think that's really sort of reflective of saying our growing environment isn't changing that much? Or there's just a lag that's kind of built into that?
So all the site index was based on the predictions from performance surveys at age 14. Even the older ones, we actually had measurements from that time, so we tried to keep that standard. Because that is a problem when you're measuring trees of completely different ages. So we did try and standardize the assessment time as much as we could in order to project site index in that one. But I think it is. I think it's real. I think that increase in productivity is real when we're walking in our forest, in our post-harvest forest. That increase in productivity is real. There's lots of, when you go into a spruce plantation, there's lots of leaders that are 50, 75 centimeters long. Yeah, I think that is happening. So we're out in a plantation, spruce plantation earlier this spring, and it had been thinned last year or earlier this spring, I guess. So we could see how long the leaders were from last year, and the biggest one was 1.8 meters. 1.8 meters in a spruce tree. That's incredible. It was wild. So this idea of trees growing slow is not happening, and this increase in productivity is happening, I think.
Almost as fast as a hydroponic. We will take one online first, and then we'll come back to the room.
Okay, sure. So the first one that came in was from Michael Cody. He asks, or wants you to comment on, some opponents of intensive silviculture point to perceived incompatibility with biodiversity. Can you comment on this?
Yeah, you're right. And that is one of the knocks on intensive silviculture is we're putting all of the resources from these sites into trees, right? So if you walk through a lot of plantations, there might not be a lot for understory vegetation, things like that. Okay, that in many cases that could be true. I would say though that one way of perhaps thinking about that is the zoning approach. Is if we had zones that we wanted to grow timber on, then the rest of them, they're not unimportant, but we're just valuing them less in those certain sites. And then on other areas of our forest, we could manage more ecologically to ensure that we're maintaining all of those values. So I think zoning is one way of getting around that. I also think we need to start widening our metrics of what we're measuring in these intensively managed forests. I think there's probably a lot more happening than we think. We tend to focus on the timber, or at least I do. But what should we be doing? How come we don't have wildlife biologists out there with us as part of these studies? We could have plant ecologists out there looking at. We could actually answer some of those questions. But I think we need to expand it. It's not just about timber; it is about all those other values too. So how do we do that? How do we incorporate that into into some of our studies? I think would go a long ways.
We had a couple at the front here that put your hands up or want to go around.
Hi, so I am a silviculture forester, but I'm going to put my operations hat on here for a second. So going back down to the single tree level, were you considering potentially log quality and at what age you would thin? So in a naturally growing pine stand that gets self-thinned, the limbs come off at a good rate. So are we growing less productive timber where you get less recovery potentially out of faster because we are creating much more leaf site for those timbers to grow? So if we're saw log potential, was that part of your consideration?
Yeah. Yes and no. So that's always one of the concerns that comes up is about the wood quality in the future, right? And there's a few things to consider here. One is just the size of the tree, but also I think you're getting at branchiness and things like that are also of consideration, and also wood strength. So one of the arguments that's made for our boreal forests is they grow quite slowly and they're hence so strong. We didn't really look at that very much. Our attempt at doing that was incorporating the tree size, and that was our 20 centimeter cutoff. We were hoping that captured some of those ideas. But this is a great discussion, and I don't know the answer to it, but When I've talked to people from other areas, my example is from the southern yellow pine, so loblolly pine. This was a concern there. It's too weak. We can't. So instead of changing how they're growing the forest, they changed the building codes. So things like that, right? So what's the solution here? And there's multiple solutions to all of these things, I think. So it is an important one. When I've asked that question to people, what I've been told is right now it's just volume. And that might be but I think we do need to consider the wood properties. So I know the folks at CFS work on wood quality and intensive management. I know, Barb, that's part of the breeding portion of it is resistance as well as wood quality metrics. But we can look at branch size as one of our metrics. We had a postdoc Barb and I did, or still do actually, but he was looking at improved versus unimproved. And one of the interesting things was that the improved stand was growing faster. So it basically was showing an increase in site index, but also had smaller branches. So to me, that was if you can find those that you're getting your better volume and you're getting better wood quality, those are the winners. You're checking multiple boxes, right? So maybe it's looking for those things as we're developing our programs that could help address that.
Take one more line and then we'll go to that.
Okay, Michael Cody just wanted to say he agreed regarding the zoning, and he said thank you. And then Robert Grant had put in a question when you were talking about site index. So he said, is enough known about soil quality, nutrient, WHC, depth, coarse fragment, drainage to associate it with SI within a climate zone?
Yes. Yeah. Right. I think we can do a pretty good job. I think we have the tools to do. We have really good soils maps for the most part in Alberta. We actually have better soils maps than most of the forested regions of Canada. We also have really good LiDAR data. So we have things like wet areas mapping. We have the derived ecosite phase map. So we have a lot of these things. We don't have soil nitrogen and phosphorus and things like that, but we have a lot of these other metrics about soil water holding capacity, about the nutrient regime of these sites. You can actually use a lot of that, I think, to do this. And there has been work done in natural forest, and that was actually part of my PhD program, was actually trying to relate soil properties to timber productivity. And we've done a lot of that in natural forest, but we need to do it in managed forest because they're just simply different. So tools to do that. We haven't.
Thanks so much, Brad, for your presentation. My question kind of got stole there up the front, but just along the lines of log quality. So we're inching towards this potential fiber basket gap. And we're going to see smaller piece sizes. And with the introduction of these aggressive silviculture practices, there is a potential, right, for lower mechanical properties in the timber that we're producing. It's a bit abstract, but do you think maybe one day in Alberta we'll be producing things outside of dimensional lumber, i.e. composite lumber?
Sure. Yeah, and so again, that maybe the 20 centimeter cutoff that we were talking about isn't the right one. Maybe the technology is going to change. We kind of developed that talking with people about what seemed reasonable, but what's reasonable now is not what's reasonable in the future, right? So we need to be thinking about that too, is what is really the value? If your only goal is total biomass, or maybe it's carbon, maybe that's our goal here in the future. In that case, we're going to be doing very different types of management, but it does come down to what's our management objective here. And if we can kind of, what are we trying to do and work ourselves backwards from that, we have a much better chance of hitting it, right? But I think if we can, in the future, I think we can talk about which tools we want to use, on which sites do we want, what are we trying to get to, what does that look like? And we can develop crop plans to kind of do that. Quite valuable discussion for us all to be having. Yeah, that's.
You bet. Thanks,
Right.
Brad.
Okay, Gord Whitmore asks, what are your thoughts on pre-commercial thinning of naturally regenerating stands and plantations that have had considerable natural ingress to prepare them for commercial thinning at a reasonable age?
Do it. That's my thought, Gord, is you should do it. But again, it's not just that simple. In general, what we're thinking about is we need to set up stands in order to be ready for commercial thinning, you probably have to do a pre-commercial thinning or some sort of density management beforehand. And in terms of natural regenerating stands with high density, that's probably in plantations, it might be just you're establishing them at different density. And you need to do a pre-commercial thinning. But some of the work that we were doing was looking at, okay, so what's our best, depends on quality though too. So some of the work that we were showing from our lab was that, okay, on poor quality sites, you actually, the best decision would be simply to pre-commercial and then no commercial thinning. So we were only looking at a one entry on some site types, whereas on our more productive sites, those are the ones that we might want to do a pre-commercial thinning followed by a commercial thinning. So it's not a one-size-fit-all approach. We need to know about the productivity of our forest to know which ones, which treatment is going to be the best to meet our management objectives. But yeah, I think that's a really important one. Is we do have a lot of dense forests. One of the things that I say in my silviculture class a lot is one of our major challenges in forestry is way too many trees. It seems a little bit strange, but the reality is that when we have really dense stands, they're simply not growing very fast. And so too many trees is actually a problem that we're facing in many of our forests.
I had a question here, but I think I missed the gal.
No worries, thanks. So I'm just curious about by improvement, do you mean genetically modified or that's tree improvement? Because I know there's some places where they've used tree improved species or genetically modified species to increase growth in a smaller time, as opposed to intensive silviculture. So what are the trade-offs between that? Also, maybe I just don't know the policy with using tree improvements in Alberta, but what would you say about that?
Well, I don't think it's one or the other. I think it's both. Not doing any competition control is a loser, right? If you're you have commitment to things, they go hand in hand together. It's not one or the other. They really do go hand in hand. But maybe in that timber production zone, maybe that's where we would want to. We're using mostly native species or local genetics. Maybe we want to do some, some improved stock. Maybe we want to expand the range of certain species for climate change adaptation. Maybe that's more acceptable. Where we'd have some flexibility to do that. Maybe it's Douglas fir expanding a little bit over the mountains or ponderosa pine coming up from the south, things like that in Alberta, which have lots of potential. They're not exactly local to these areas, but they're the future local species in many cases, right? But beyond that would be things like Siberian larch, which can grow great here. It's a step further than that. Is that something that we're willing to accept in these zones? Those are all discussions that I think we should be having, and it's those ideas of what are our current rules and our current metrics? Are they meeting our future goals, or how flexible can we be on some of those? And to try some of these things, I think would go a long ways. But in terms of the tree improvement and silviculture, they really do go hand in hand. I don't view them as one or the other. I view them as both. Yeah, in BC, it's what, 100%, isn't it? Like, yeah, so. Yeah.
Thank you, Brett. I have two questions. First one may be very naive of me about the topic. There is usually inverse relationship between quality versus quantity, right? When you focus on the quantity, you might losing some quality. I'm not sure any studies on this topic. For instance, if you bring a wood from North Carolina, which is they grow what 20-25 years versus Alberta is 100+ years, can we really compare the wood quality the same? I assume not, but I'm not sure. I will not answer.
Right. Yeah.
Okay, let me ask my second questions. When look at the natural trajectory of the forest from the seeds to all the way to mature forests, what happens? There's a source dynamic, right? They rely on the trees as a sink, really. They rely on the soil, the nutrients and water, everything. When they grow older, they put it back, they return back to nature, right? So nature can act again. There's a really positive loop. If you go to your intensive harvesting, I assume, I'm not sure, you are affecting that sink source dynamic that's settled in the boreal forest. Thank you.
Okay, I'll try to those. Here is, yeah, so it's kind of a quality versus quantity thing. So it's total volume versus the value of the timber that's being produced. I think that's a discussion that we should be having and thinking about, what do we really want? Are we willing, it's all about trade-offs, right? Are we willing to wait longer and harvest less, to wait to get those trees? That's the question. And from my discussion, people, it's right now it's volume. They're willing to take, lesser quality volume just to have the volume. So is that going to be the case in the future? I don't know, but there is some trade-offs there. I think we can be thinking about. But again, are there some winners that we can select, some treatments, some families that we're producing in our tree improvement programs, whatever? Are there some that are kind of meeting both of those objectives, increased growth and better wood quality? I think there are. I think there are winners in that way. In terms of the source sink one, so this has been a big issue in some parts of the world where we were thinking about, okay, so we're removing this biomass from the forest, it's not going back, that's going to decrease the long-term productivity. And I think that is a risk in some places. I think particularly in when we're dealing with coarse textured soils that are highly leached, when we're dealing with shallow soils. So that's not what we have in Alberta. I would say our risk, most of our productive forest land, when we're dealing with loamy soils, deep soils, is actually very low in terms of that. I don't think that's a substantial risk, at least in the, but that would be something different. This being a big risk, usually on sites which don't have much nutrient capital to begin with, and that's not what we're dealing with here. So again, this comes back to our soils being great in Alberta, and that's one of the benefits, is that's less of a risk here than it is in other places.
My main focus was really not about tree branches or needle leaching. It's more on the root oxidates, right? Most of the soil carbon comes through the roots, root that releases a lot of carbon-based chemicals in the soil. That is the dynamic of the driver of the soil, microbes and everything, decomposition. If you take away that component, I'm not sure how the soil feels about that.
Well, I don't know either, but it sounds like we should have a research project here going, hey? Yeah. So, but again, that's maybe. There are lots of unknowns about this, and so moving beyond timber, what else should we be looking at? And that's maybe an area that we could be looking at. We've got enough of these sites available to us now. Yeah, right on.
Thanks, Brad. It's really good. I haven't thought about this stuff for a long time, so I'm going to ask some potentially silly questions. I'm pretty convinced, especially if you use the allowable cut effect, but you didn't present anything about costs and whether you've done the stand level or landscape level NPVs. Maybe they're buried in there somewhere. I'll leave it with that one, but I want to follow up on the deers. You talked about climate change adaptation and maybe following up on the question back here, but what about mitigation? I mean, the new social cost of carbon estimates suggest renting carbon sooner could be a big payoff, which would be consistent with your story. If we can sequester faster, that might be more important than many of the things you chat about.
Yes, I think carbon could change all of this. So I'll maybe start with the economics one. Is we tried doing that, and we tried to put it in a paper, and we're told we weren't economists, so stop trying to be one. And I agreed with them because we're not. But I think it's we need to incorporate that into it, right? We do need to be thinking about this. And how do we do it? It makes sense when you own the land to do net present value. Does net present value make sense on public land where you're leasing it and we're talking about a different way of doing timber supply analysis? I don't know. But maybe that's something that we should. One of the things that we've done, the way I did try and do that is, okay, when we started this project with Bob Winship, he kind of said, there's different ways of getting volume. Either you grow more or you buy from somebody else or whatever. So we know how much it costs to buy timber or to buy AAC from somebody. And he had a number for it. And we know how much it costs to do thinning. And the basic assumption was that than buying wood elsewhere. So that analysis of it, but that's one way of looking at it. The other one about carbon, I took the slide out earlier, but the other thing that you see, carbon is interested me a lot, is that as we move into managed forests, we actually, the big carbon bomb I see in our forest operations beyond just trees is big brush piles. And actually our managed forests tend to have a lot smaller brush piles. So I think there's lots of ways we can start incorporating this idea of carbon into it. An interesting thing last year at the Society of American Foresters, I tell a story a lot, but I think it's quite telling. The two biggest sponsors were carbon companies. They weren't Weyerhaeuser, they were carbon companies. So this is in North America, and it's starting to be a part of it here in Canada. So how is that going to change? Does the value of the trees, is carbon just going to be the most important thing, and how quickly we can harvest it and get it into solid wood products and long-term storage? Is that the most important thing? In which case, I think you're right, it does make this even more important. If it's about standing volume or about standing biomass, again, objective, and then what are the tools we have to get there? I think that's the basis of all of this, is what do we really want from our forests? And that's a really much harder discussion to have, right? It's not about the tools, it's about what do we want from our forests.
Darcy Giroux, sorry if I mispronounced your name. You mentioned having a wildlife biologist in these stands could be beneficial. However, is there any anecdotal evidence of increased or decreased wildlife use in these stands? Example, fewer moose with decreased available browse like alder.
I don't know. I don't know the answer to that, but I think it's one of the unknowns that we've got here. Of all the things that we know, we're pretty good on the timber side. We can predict timber growth in response to treatments. We're good at that. These other parts of the equation, I don't think we've made the same effort and have the same information to answer them. So that's what I think, if we're looking at what are some of the next steps that we need to quantify, it's things like that. It is about wildlife habitat and biodiversity and all of those things that go along with it, because that has to be part of the story. We start with timber, and my bias is clearly about timber. Vic said he hadn't thought about this for a while. I think about it way too much, so that's kind of the trade-off there, I guess. Putting more of these things into all of our studies. So we actually do have a project starting looking at variety of different thinning treatments, pre-commercial and but looking at that's going to be part of it. We are going to be looking at understory plant diversity and other things like that as part of the analysis. We wanted to make sure that became a part of it because it is important. It's more than just timber. Better for mountain biking, yeah. There you go. All these values, recreational values, right? Yeah.
Question from the floor?
I just have a comment. Don't forget to bring an entomologist out with you.
Okay, there you go. We need lots of people, but I think this takes more than just. This is more than just silviculture foresters. This is more than just foresters in general. We do need this. This needs to be really holistic. These discussions, right? We do need to incorporate all these different values into the decision making, and we need to understand the impacts of not just intensive silviculture treatment, everything that we're doing out in the forest. We really do need to have that a broad understanding of their impacts.
Can I make one comment?
Okay.
It's just about Nadir's question about quality versus volume. And it is a huge concern because there's a negative correlation between growth rate and wood density, particularly in spruce. And so there is a bar kind of set in programs to not go below a certain density level to make sure that you can select above and still get your growth rate. So you're trying to get both at once, but they're negatively correlated. So it's always a challenge. And it is, as we get into more advanced generations, it gets more severe because they're growing that much faster. So it's the integration with the silviculture and those treatments, commercial thinning treatments, critical. Yeah. I don't want to have the last word. So you have the last word.
Okay. Well, I don't know. Yeah, there you go. Nadir summed it up pretty good. I think when I look at the future here, I think there's a lot of potential for intensive silviculture. We're gonna need more variety of silviculture. We're gonna need more intensive silviculture. Maybe the next talk I do is gonna be on ecological silviculture, because I like that too. But we're gonna need a lot more variety of silviculture, of different forest management treatments in general in our forests. That's what's gonna be, I think that's what's gonna be demanded of us in the future as foresters. So let's start getting prepared for that now.
All right. Well, please join me in thanking Brad for a fabulous kickoff. A great way to start our series for this winter. So I'd like to thank all of you for coming here today and all of the folks online. It's wonderful. We can bring in people from right across the province and actually in the prairies. I think we usually have people coming in from even Brad's mom, I think.
Is my mom on
That's great. Of course, none of this is possible without Stacy, so please join me in thanking Stacy for all her work. She's unflappable when we have these crises that occur. Always a couple of announcements. Our next speaker is going to be Troy Stewart. Troy comes from Big Stone Cree Nation, and he will be speaking on October 5th, you know, as we have a speaker every month. So we're really looking forward to Troy coming. He has not given us a title yet, so we will be advertising that as he provides that to us. And then in November, of course, we have our regular Phil's seminar, and it's not just a regular Phil's, it's two things. It's our 90th Phil's, which is remarkable, and our own Ella McDonald will be our speaker. And that will be on November 2nd. And she's going to speak on revisiting ecosystem-based forest management. Do we really want to emulate natural disturbance? So she was a little, I think, surprised at her own title that she came up with when it was said out loud. So that should prove to be very, very interesting and a great day and evening. And with that fall forestry Phil's, there is the dinner at the University Club, and it's where we highlight our undergraduates. So all of the undergraduate forestry students are invited to that dinner. So please mark it in your calendar. We really are trying to get all of the undergrads out to meet with our sponsors, to meet with the faculty. And the first year sometimes kind of go under the radar because they're off doing other things, but Brad's going to make sure he ropes them all in. Peter, who's Peter? Let's see who Peter is.
There we go.
Yay, Peter. Okay. And Stacy, who also runs Phil's for us, will be looking for help as usual from the undergraduates with registration, banners, et cetera, et cetera. We do not have a location yet. And I think with that, we've had a wonderful afternoon, a great start to the series again. And thank you all for coming. Have a great start for your September. Maybe there's some volleyball still going on out there. I don't know. Okay.